This is the video presentation for Into the Woods. Team members are Andrew Stevens,
Miranda Figueres,
Karen Kaur,
Warda Aziz,
and Mason Triago.
First, we're going to go into how to install and set up Into the Woods. So first of all, the user has to make sure that they install the Java JDK of at least Java 17. After that, they're able to run what's called a jar file. The jar file can be downloaded from wherever the source is, and they can bring it to whatever location on their desktop that they want. For both Windows and Mac, it works the same way. The file will be placed down on the desktop, and the user will have to right-click and open the jar file. When the user opens the file, what will appear is the game. I'll leave it up to Miranda to start talking about the main menu.
So the user can get to the main menu by clicking the Start button from the Start screen. By clicking the New Game button, the user is led to a page where they can choose the avatar they would like to play with. There are currently two options of avatar, Teo or Mei Lin. After selecting the avatar the user wants to play with, they will press the Start New Game button, or they can choose to return to the main menu. It should be noted that the user should only start a new game if they definitely want to start a new game, as the previously saved game will be overwritten. The Continue Game button will lead you to where you can select which level you'd like to start with. It should be noted that because the user hasn't completed a level yet, only the first level will be available to select. But once the user has completed a level, their game would have been saved. So if they close the game and reopen it later, they have the option to select at the next level in the progression. By clicking the Options button, the user is brought to an options page where they can adjust options including the frames per second, the window type, the window dimensions, and to have sound playing or not. Frames per second can be adjusted from 24 to the highest frame rate set in your system. The optional window types are windowed, windowed list border, full screen windowed, and full screen exclusive. The window dimensions are adjustable from 1024 to 576 up to the max window dimensions of your display. And the sound can either be enabled or unchecked to be disabled. Once the user changes the settings to match their preferences, they need to press the Apply button for those changes to take place. Then they can select the Back button to the main menu where they can start their game. The Help button will lead the user to the Help menu, which gives them information on 3 specific topics: the game objectives, the obstacles found within the game, and the game controls. The objectives will describe player needing to find keys in order to complete the level and open the door at the end of the level. The obstacles described include spikes, which will instantly kill the player, gas pockets that help the character jump higher, and the platforms that the player can either walk on or use for wall jumping. And the game controls tell the user the key commands associated with moving the avatar within the game.
Once the user's selected character enters the game, it will land in the first level. The objective of the game is to acquire all the keys that are placed throughout the level. The user has to use key controls to maneuver the character. In order to get to the keys, the character needs to jump and climb platforms. There are also gas pockets in the game that allows the character to jump higher. And the user needs to make sure to avoid the spikes, otherwise the character will die and the game will reset. Once all the keys are collected, it will be required to find the door that will lead the character to the next level. And if throughout any time of the game you need to pause or read the help menu again, there is a pause option implemented in the game.
In the moment when the user is in the middle of the game and they want to stop, they have to press the escape key on their keyboard for the pause menu to appear in the screen. The pause menu consists of 4 options: resume game, options, help, and exit to the main menu. Each button is a different option and will either assist the player in continuing the game or leaving the game and returning to the main menu. The other 2 buttons will bring you to the options page or help page to further assist the player with the internals of the game.
So first off, I would like to note that all the sprites and backgrounds were created on the application called Asprite or MSPaint.net. The next 2 art styles that are mostly used in this game are pixel art and abstract art. I mainly use these 2 art styles as pixel art brings a huge homage to any game that each of us has played in the past, like Super Mario, Metroid, or Contra. Pixel art, in my opinion, is the easiest to animate, and abstract art is mainly my art style.
So we'll start talking about the save system. Because a jar requires that all contents within the jar remain the same state, the save file has to exist outside of the system. To save the file, all the user has to do is complete a level, apply settings, or exit the game. Any of these 3 states will cause the user to create a file on their desktop or wherever they saved wherever their program is located, and it'll be saved to a savedata.json file. This file exists as a JSON file, which is a flat file type that contains all data relevant to the user's save states. This save file contains level progress, the selected character, which is Teo or Malin, the dimensions of the screen, the type of frame of the screen, the frame rate that was selected, and whether or not the audio is enabled or disabled. This file can be deleted if the user wants to reset all settings, but if the user wishes to move the game location to a different folder, the user should move the savedata.json file with it to avoid losing any saved data. From a development standpoint, Into the Woods was not an easy game to develop. This is due to game design requiring a good knowledge of data structures, and in our case, a good knowledge of Java. Into the Woods is a game made from scratch. A lot of time went into developing every single component. Very few components are derived from libraries. Many of the derived libraries are from Java's proprietary libraries. Another such library that was used is JavaZoom, due to the fact that Java removed their audio utilities from the standard packages. Another library that we used was JSON. We used JSON because we needed something for JSON parsing. Into the Woods contains many features, and while they're not groundbreaking, they are new to developers who have never set foot in proper game design. Our system features dynamic system scaling, which is particularly impressive because it allows for modular window scaling. It features a frame rate limiter where the frame rate can be selected by the individual playing. And it also features update normalization, using delta change in order to figure out how components should move in the game environment without having to worry about update rates causing weird behavior. Into the Woods features a basic physics engine, which contains boundary boxes, and with those boundary boxes, inelastic collisions and gravity functionality. We've developed a menu subsystem and a game subsystem separated but composed within what's called an environment handler, which allows for complete control between two separate environments. Our menu subsystem contains menu navigation between multiple elements of the menu system. It also contains multiple custom UI components, which handle various different types of interactions with the mouse. These modular components have different declarations for their functionality and are declared based on where they are in the menu system. For instance, a menu slider can be used for both changing frame rate, but the same menu slider type can be used to change the window scaling. We've added resource management and performance optimization as well. Our resource management contains a singleton resource pool type. This assists slower systems with the caveat of requiring more memory to be allocated during runtime. These resources are created at initialization or allocated during initialization. There is also an intelligent resource recognition system, which asks a metadata file to retain information pertaining to certain files that should have existed inside of the project in order to be used for later use. These resources are retained within a resource pool, and these resources can be named by name through hash maps. We've added what's called sprite sheet animations. Sprite sheet animations use custom sprite sheet readers based on JSON. Our sprite sheets are created through Asprite. The PNG files and the JSON files are both kept locally inside of the jar. These sprite sheets are animated visuals, and they allow for low system overhead because they follow a singleton instance. Our audio subsystem is also located within a resource pool, which incorporates an external library called JavaZoom, as mentioned before. But JavaZoom is incomplete for what we needed, so we needed to incorporate more in order for JavaZoom to properly function within our system. This added functionality gave us more control over audio files. JavaZoom was added primarily because Java discontinued their MP3 file format, so we needed something to cover that. Without the use of MP3 files, we'd be using WAV files, which are far more bulky and require much more storage space. These audio files can be played anywhere within our system during game time or within the menu system by calling on reference to the resource pool and calling on the specific file name. We've created a file save system using the JSON parser. The file save system saves files directly outside of the jar. This allows for the user to have full control over their save file. Our game can support many objects, many entities at a single given instance, due to the way that we've developed the memory management of resources like images. A chase camera has also been created for the game, which allows for more fluid-like motion where the player moves, a camera follows closely behind, but is always playing catch-up. This gives a more lifelike feel to the game while playing. We've also added what's called a parallax background. It's a background which moves based on how the user moves, and there's different layers to it, such that the farthest back layer moves slower than the front layer. This gives a feeling of depth while playing the game. From a statistics standpoint, we've put hundreds of hours into developing this game. For the code alone, there are 85 classes, which are custom built. There are 2 libraries used, 6,100 lines of code, and 2,300 lines of Java doc. This game was mostly built from scratch, save for certain utilities and top-level swing components. This was all done within 2.5 months. Needless to say, my team is very proud of the hard work and dedication that we've put into developing such a software. So much time and effort has been put in, and we feel like it reflects the product that we've developed. We hope you feel the same way too.